Take a wander from the moon. You take a line from the sky. Hey, ROS developers, here you are again for another ROS live class today. I'm very happy to have you here again. All of you, I see that you are a lot there and that you came last week and all the other weeks. So I'm happy to start building some community there. And yes, music things apart. So let's start with today, last class on how to build ROS State Machines in an easy way. Okay, so I have one bad news and one good news. The bad news is that we cannot use today yet the completely graphical system for developing state machines. So if some of you want to leave now the class, that's okay. I understand. Well, the problem is that in order to do that, we need to use ROS Kinetic on the ROS Development Studio, on the RDS, and we still not have it. So we are working so hard to integrate ROS Kinetic into the ROS Development Studio, but still some things are resisting. As you know, in the RDS, we are using ROS Indigo now, and we are doing the transition from there to ROS Kinetic because it's the newest and is the most modern version of ROS. But as you probably know, we also have the Academy, the Robotic Night Academy, and many things depend on the version of ROS at the Academy. So we have to check that everything is working there. So this long story short, we still don't have Kinetic, so we cannot use visual states for building ROS state machines in a visual way, completely visual way. So, okay, that's the bad news. The good news is that what we are going to do is to continue doing ROS state machines using the R commander. So we can build some semi-graphical state machines using the tool that we used last week, if you remember. And we are going to use now this for doing grasping with a very super nice system in simulation that JdeRobot has created for this. So we are going to experiment with a robotic arm and a robotic hand gripper with 3 fingers, I think it has. We are going to check in a minute. So if you are still with me, let me check. There's still 13 people there on the class. That's great. So if some of you want to leave right now, that's okay. For the others, start sharing your emails there on the chat, and I will start sharing with you all the code that we are going to use today. So please start writing that there, your emails. In the meantime, I'm going to open I'm going to share with you my screen so you can have a full vision. And let me just share here. Okay. So here, let me tell you about this address. I'm going to put this beneath the video, okay, afterwards. So this is the webpage that we have built for our live classes, and where you can find all the classes that we have done. And we are going to put here all the upcoming live classes, so you can schedule yourselves in the future and say, oh yeah, so I'm interested on the next one that is ROS Industrial, is on 28, so I'm going to reserve my time on this, and we are going to put more. Okay, so it will have here about 1 month of classes before so a schedule already, so you can plan yourself. Great. So nothing more to say about that. I will share this link with you beneath. So now let's start with the sharing. All the code that we are going to use here is for the class number 11. So let's start copying emails here. And let's put it here. Okay, so when I reach the end, that will be the last user that will have his code. So his email. So I will share. That will be the last user that I will share the code with. So in case that you want to have access to the code now, write your email, the one that you use on RDS. Okay. So it's not your email per se, your normal email, but the email that you have used to create an account at the RDS. As you probably know, the address is rds.theconstructsim.com. If you check my my webpage here on the screen, you will see the domain name. So I'm about to finish with another one pop up. Darek here. Popescu is the last one. So if you want, you are 3 seconds more. Nobody else. 3 seconds. 1, 2, 3. Okay, it's done. So here we go. Oh, error. No way, man. No way. So, okay, so we have an error here. Copy pasting. And this is, damn it. I thought that we have solved this already. And I don't understand why. So let's go. Okay. Error. Okay. So let's use the engineering approach. No, it's not going to work. Damn it. Okay. Some minutes more to send some emails. Okay. The first one is the one that is missing. Okay. Let's start. That is producing the error. Let's go with this one. Oh, okay. So it's any one of those. Let me close this. Come on. How can we be here again on the same closet? Okay. So I don't know, but there is something wrong in here. Really? Okay. So we have a problem here by sharing this project. Let me check another one. So let me share this one with Vinju. No, it's on the side. Let me refresh. Oh, okay. Yes, I know. It's because I logged in with another account and then I had the page. I'm sorry, my stupid thing. So, damn it. Okay. Now, Vinju doesn't exist. Yeah, well, Chris says, time to call the web developer. No, it's time to hang the web developer. It's time to... Okay, so yeah, Eugen, Binju, you have something wrong. Robin, you have something wrong in your email. Okay, so let's start again. Okay, so Egan Paul, you have yours. Actually, it was not his fault. Okay, so the problem was that I was logged out and logged in with a different account, but the web page was using still the old one, so it didn't match it. So, okay, so here we are. Okay, let's see. And almost there. Stay with me just a few minutes more. Minutes, no, seconds. Just a few seconds more. And let's see if this is working properly. I think it is, because we work on solving the problem of the copy pasting. I mean, it has to be solved because we dedicated especially the time for this. So let's go. Okay, it's getting in. Now, let me see if somebody else appeared. Yes, okay, all files shared correctly, so you should have received it. Then Robin, you have a problem in there. Let me try it again. In the meantime, all of you can get into open the project that you have received. Let me know if some of you haven't received it, in case that some error also popped up. But let me just retry with Bingu. Trying again, Bingu. Okay, doesn't exist. So it's not a username in the RDS. Please check it out. Let's go. Let's open the project. And let's go to here. Today we are going to do something special. So you're going to learn and use other tools, and it's going to be interesting because we are going to change things. So first thing, let's go and launch the simulation that we are going to use today. And for that, you go to simulations and then select here the where is the shadow robot. We have the shadow hand and the shadow robot. Select the shadow robot. Okay, so select this one and wait until it opens. Hi, Gao says he has not get the project. You have to refresh, as Epson Warco is indicating. Yes, please. Hi, refresh it in case that you haven't received. Let me know. But I mean, this process doesn't fail. If it went through, then you should have received. Okay, so the simulation here is opening. It's quite a complex simulation, so it takes a while. Then in the meantime, I hope that you are launching this and the simulation is running, so it's doing a lot of stupid errors. Don't pay attention to those errors, just details. Okay, so the simulation appears here, as you can see. And if you go out a little bit from the Zoom. Okay, hi. So I presume that you have received it. Okay, great. Then good. So you should have this simulation, right? So if we put it bigger, we can see the whole scene. So we are going to use this arm and the gripper here to grasp the ball. So the good news is that everything is already created. You can play with it and recreate by yourself, but we have to go fast. We only have 1 hour and we have to go as fast as possible. You will have the material to work with it in your free time. So that's perfect. Let's go now. Let's open. We are going to open a notebook that contains many instructions already made in order to learn how to do this, how to use this environment for grasping. So for that, you go to Tools and then Jupyter Notebook. So if you are here in the Jupyter Notebook, should open something like this. And as you can see, there is a directory that calls a Smart Grasping Sandbox. If you open this one, then you will see that there are several, as you can see, notebooks. You see the icon is a kind of a notebook. You see several of them, okay? Those are provided for you by the files that I have shared with you. So let me just put this a little bit aside here and open now the IDE here. And let's see the files that I have shared with you. So I have shared some files here in the Catkin workspace that are related to the simulation, to the SMAT machine that we are going to use. Okay, here in the simulation workspace, we have nothing because the simulation that we are launching is one that is already integrated in the ROS Development Studio. Okay, so nothing related to the simulations. We have coded in Catkin workspace, and also we have code here in the notebook workspace. As you can see, this notebook workspace is the one that contains this directory that we have opened here in the Jupyter Notebook. And then inside that is all the notebooks are there. Yes, and other information, other files that are necessary for some of the notebooks. Those notebooks have been created by Shadow Robot, by Hugo Kuptik. And so we are using it because they are providing that for free. And in this case, today we are going to use the Smart Grasping Sandbox. So you just click on this one in the Jupyter Notebook, and then it will open this notebook. Great. So I presume that all of you are following. Just in case you have problems, just let me know, because I have the chat there, so I can see when you are in trouble, and I can try to help you. Great. Now, what do we have here? It explains a lot of things here. And we are not going to go into this, because today we are going to work with the SMATch. We are going to create a SMATch machine. But the thing that we are going to do first is to see what we want to accomplish with the SMATch machines. So for this, if you follow the explanations, we are going to execute here an example that makes the robot grasp that ball there. Okay? So then do the following steps with me, okay? You can experience later by yourself. But now let's go. So first, you select this cell that contains the number 1. Select that. So you should have this green stuff around. That means that has been selected. Then you don't type anything here. Just execute this cell. And this cell is going to initialize the grasping system for this robot and this simulation. How do you start this? Is by pressing this icon here. You see, run cell selected below. So press this, and then you see that the number here changes from a number to a star. When this happens, it means that this cell code is being executed. The smart grasper takes some time to initialize, but after it has initialized, you see the star has disappeared, and then it has printed this. And you can see in the simulation that everything has been initialized, and the robot has been set on a position in order to be able to grasp the ball. Yes? So far, so good? Any problems? Did you achieve to get the robot in this position and have it executed there? I presume yes. Okay, now it's time for us to execute the code that picks the ball. For that, this is written here in this other cell that says number 2. And then it executes this Python function. Of course, this Python function is already being created by JdeRobot in order to facilitate for us the grasping thing. And today we only want to use this, don't want to get into details. If you want details, they are below a little bit, okay? So just check it. Then what are we going to do? Just press this cell and execute. And you will see how the robot starts grasping the ball, as you can see here. Okay, it grasps and then it lifts it. Great. Okay, so it should be like this for all of you. Let me know if you are not. Like this. Well, yeah, the ball is kind of moving in between the fingers. If you select the ball, you will see that it's moving around because of the collisions, of the way that the gazebo simulator treats the collisions. And then it's not 100% like reality, okay, but it's close enough, okay, for us to do the grasping, as you can see. Okay, so far so good. I don't see any comments, so I presume that everybody is working. It's going okay. So next step. Next step is to reset the wall. So let's reset the wall so we can create a new grasp. So if you select cell number 3 and then press the button, then everything starts again. And you can see the robot has released the ball. It's prepared for grasping, and the ball is there. Okay, so I presume that you are following. Then one interesting thing is that you can put the ball in a different place of the table. For example, I'm going to move it here, and you can select the position and then select again the cell number 2. And we select the cell number 2 and we launch it again. So the robot is going to adapt to the new position of the ball. As you can see, is grasping on that new position. That is quite interesting, isn't it? Because it's very easy for you to create a grasper here. All the kinematics have been dealt within this function, the pick function. And so that's very convenient for all of us, okay? And then we can reset again the wall and start again. Let's put this ball on another place. Remember, always when you move the ball, you have to press again this arrow in order to actually set the position. Until you don't press that arrow, the position is not set on the simulator. Okay, and then execute again. Okay, so basically that's the procedure. Okay, so what we're going to do is to create a state machine that does all this all the time, so continuously. So it grabs the ball, resets the wall, waits for some seconds, and then grabs again, resets the wall, etc., etc. And in the meantime that the robot is waiting, you can move the ball. So you can make it a trick so it has to readapt while this state machine is executing. So that is very interesting for a demo, for building a demo. Yes? Okay, so any question about this? If there are no questions, we know the code. And what we have to do is to come here to our code and into the Catkin workspace. But before, let me tell you that I have included here some other notebooks with different types of grasping, including a deep learning one, and including the models for the deep learning. Those models have been created by JdeRobot. Then you can experience with those. How do you open other notebooks? Well, you come here, open, and then you get the others. So reinforcement learning hand, and then here you have the code. It's not so explained, but at least you have the code and you can see how it works. And you can execute this part, see what is the result, etc., etc. So I recommend you that afterwards you take a look at this because you can learn a lot. So in this case, we have the smart grasping sandbox here. And now let's go and create this match code that is going to do this demo all the time. Okay, so let me reset the wall. So I'm going to select that cell and then reset the wall. And something happens. Yes. Okay, yeah. That's because I have changed the notebook and then all the code that was executed is broken, etc. When this happens, this is how notebook works, okay? So when this happens, the safest way is to come here and restart the kernel, okay? So if you press this button here, that is like a reload button. You press this button, then it says, do you want to restart? Yes, you restart, and then everything that has been executed in this cell is not available anymore, and you can start from scratch. So we have to start from cell number 1, press run, and then everything will restart here. You will see. Some seconds, yes, so it's start, then we can pick, we can reset, etc., etc. Okay, but we are not going to execute this anymore. Let's go to the state machine. So for that, let's go here to the IDE, and let's go to the Catkin workspace, as you know. Then remember that in order to be able to use the R commander, we have to do a small command before we can use it. Okay, so it's a limitation that we still have in this R commander. So for that, let's go to Tools, open a shell. And then let's go to the following directory. In this case, is the Catkin workspace, then is source R commander core notebook qt. Then here it was source, and it was notebook notebox qt. I think it was that one. No, not that one. Sorry. Okay, let me check it. It was notebook box qt source graph. Here it is. Yes. Okay, so it's notebooks qt source, still source, cd source output Qt. Okay, so let me see what is happening here. So I have something different. Oh yes, yeah. So I am already there. Sorry. So is Catkin workspace source R commander core node box Qt source then graph, and here it is. And here we have to do Python setup install minus user. Python setup py, sorry. Setup py. And that's it. Let me copy the message, the command here on the chat so you can get it. Okay, so if my mouse allows me, copy and paste. Well, there was something wrong in the spaces there, here. Okay, so once we have this, let's go and let's start building our commander for controlling this arm. So for this, what do we have to do? Remember, we go to the R commander directory. Let me know if you are not following, okay? If you are stuck at some point, let me know. So we go to this R commander plane directory that is inside the R commander core. R commander core, R commander plane, then inside here on the source. So we have the place where we have to create our Python classes for the R commander. So we can use later on the graphical interface, if you remember from the previous class. Okay, so here we have some examples that we have created, especially here we have the state of the takeoff. If you remember, we created this on the previous lesson, on the previous class. And we are not going to use that one. Instead, we are going to use another one that is, let me see. It's another one that it's very similar to the sleep tool. So you can copy this one, sleep tool, copy and duplicate. Actually, you can duplicate. So once you have this, let's change the name from sleep tool to pick tool. Pick tool. Remove the one. Pick tool, and let's open. Okay, so far so good. So then what do we have here? We have to change those classes in order to execute. The goal is to execute this code here. Okay, so this code here, and create a state that will do the pick. So we'll create two states, one for the pick and another one for the reset wall. Let's start with the pick first. Okay, so we have here one problem, okay, because the state that we are going to create, this state can only execute the pick function, but not this creation of the grasper. The grasper is the class that handles the whole initialization of the system. And then afterwards, when we have this instance of the grasper created, we call the pick function. But how do we do this? Because afterwards, we'll have to also to use the same grasper to do the reset wall in a different state. But if we create this grasper in the pick state that we are going to create here, this will be not available in the reset wall state. So what do we do with this? So how can we use the same grasper in the pick state and the same on the SGA and the reset wall? How can we do this? Okay, for that we need to do some small modifications into the R commander launch file that we are going to to launch. If you remember, on the previous lesson, we were using the R commander 3. So this is the Python file that we were launching here in the launch file. That we were doing this R commander launch. Okay, so this is the one that we were launching. Let me put a little bit more bigger this, yeah, okay. Let's put it whole screen. Great. So then that was the launch file that was launching the R commander 3, this one here. But now we need to modify this so we can accommodate our code for the creation of the Grasper class here, of the Smart Grasper class. Okay, so we are going to create this Smart Grasper class here in the init, in the initialization of the R commander. We are going to create it here, and then we are going to pass this as a class into all the states. So by doing this, all the states of the state machine will be using the same Grasper, Smart Grasper class. So that is how all the states can use the same Smart Grasper to do different functions. In this case, pick, in the other one, reset wall, whatever. I hope you understand this. In case not, please ask questions on the chat. So then I have started the work for you, and I have created the grasping launch. Here, it's already there. I have created for you. Let's open it. Grasping launch. And then what it says is basically is exactly the same. We can change this as an XML and put it bigger. So this is exactly like the original one, the R commander, but that we are launching an R commander grasping Pi that is different. Okay, so let's create this R commander grasping Pi according to the grasping state machine that we want to build. Okay, so this is already created for you. You don't have to, but we need to create this R commander grasping.py. For that, let's go to the R commander 3 and let's duplicate. So duplicate, then rename, and rename as R commander grasping, of course. And let's open it. Then what do we have here? Okay, so what do we have to modify? Well, just a little, and let me explain you. How does it work? Well, you can create, in order to pass a class into the different states, you only have to create the class here, then define the class here, then you create an instance, and then you provide that instance into the run commander when you launch the run commander. In the previous case, we were passing this stupid robot class that does nothing. That was just an example. So what we're going to do is to modify this in order to include the creation of this smart grasper. Okay, so how do we do this? It's super easy. This is very easy. And let's go, let me put it here so we can see all the code at the same time. And here, what we are going to do is my robot class. We can say my robot, or I would change even to my grasper class, because it doesn't matter really, but just for consistency with the names and everything. Then my grasper class is going to be called my grasper. And here we just, instead of doing this self of some resource, what we are going to do is to create a self, for example, self dot this. We are going to use this sentence here, exactly like that. So far, so good. Are you following? This means that inside this class, we are creating the smart grasper. So this is going to be created for the first time when we launch the whole R commander. And that is good, because then we don't have to care about creating all that. Okay, still some small modifications. In order to be able to do this, we have to import all these libraries here. So let's copy also and paste here. We can put here some information like imports from Smart Grasping Sandbox. Yeah, okay. Great, so we have created the class, we have imported these important things, and then let's create an instance of this. Instead of robot, let's call it Grasper, for example, and let's substitute here, instead of my robot class, my Grasper class. And again, we have to go here where it says robot, and instead of say robot, we have to say Grasper, because it's the name of the instance that we have done today. Okay, so far so good. So we have provided the R commander with all this code. Okay, so now you know how to include this special code into a state machine, into a graphical state machine. Now, let's go for the creation of the class of the state. That's the one that is going to allow us to pick the ball, actually pick the ball. Okay, so how do we do this? Well, as I mentioned, with this pick tool class that we have done. So you save this, you can close this launch because it's already done. The R commander is also done. You can also close it if you want. Well, no, let's keep open just to make reference, to understand better. Great, so we have here the pick tool. In the pick tool, let's go step by step. Please ask me questions if you are not following, okay? Then in the pick tool, we have to create the state that will execute this code, the pick. Yes, so let's call it the pick match state. So in some place here, we have to have the pick match state. Okay, here beneath is here. So first we have to create the match state. Okay, so let's call it, instead of my sleep, pitch match state. Great. Now, here, let's change the execution of this because we don't need a sleep time, so we can remove it. Remember that we are creating this from a class that already existed. Okay, so then we have the outcomes that I'm going to call it, actually, I'm going to call it outcome 1 and outcome 2. It's just an example, yeah, and we don't need input keys or output keys now, so just remove it, or you can leave it. Okay, just I'm simplifying here. Then we need to do the execute function, and in this function this is exactly the function that is going to execute the code that we want to execute, and is this pick code. So we have to call this. Okay. So this ROS rate goes out. This start time goes out. Actually, everything goes out. Yeah. So you can remove everything. Great. Then what we are going to do here is execute this code. Okay, should be something like SGS pick. So I'm going to write it down, but it's not correct right now. Okay, let's go step by step. I see here a question. Let me just get. Sorry for coming late. It's possible to share the project later. Yes, we'll talk about that later. So I will share this with all the people later. Okay, so let's continue then. We have to execute this pick code, but we don't have this class here yet. So what the R commander provides is a function that is called setRobot. So for any pitch match state that wants to use this class Grasper, you have to define in the pitch match state, you have to define a function that it's called setRobot, set_robot. It always has to be called like this, okay? Self and robot. This is a function that is going to be executed by the R commander when it creates this pitch match state, and it will provide here the grasper. Okay, so what we have to do here is we are receiving here as robot the grasper, and then we can indicate here, okay, for this class, let's store as grasper the robot provided. Well, robot, you can say whatever. So I mean, it's I put robot because it's on the instructions that say robot, and I didn't have time to modify, but it's okay. So here in robot, we are receiving from the R commander this grasper. This is internal functioning of R commander. Okay, so you cannot do anything about that. So because we have created the grasper here in the R commander, when we launch the R commander, this is provided to the R commander, and the R commander sees, oh, there is a match state, so I'm going to execute its setRobot function, and I'm going to provide here the grasper. So what we do is, okay, let's store in the class itself the grasper. So now we know here that grasper is in the robot. So what you can do here is, in order to call the pick function, is as simple as saying, for example, let's call it result equals self dot grasper, and then remember that this grasper has the SGS pick function, okay, because grasper is the whole class here. Grasper is the whole class, and then inside the grasper we have an SGS, and inside the SGS that is of type smart grasper provides the pick function. So that is why we have to write it here all that much. Self grasper, that's the one that we have picked here, and then SGS pick function, and that's it. Well, now we have to here to provide the result, the outcome. So if result, I'm not checking this, so it equals, I don't know what is the actual result. You check it for me. Then return outcome 1, else return outcome 2. This is just to return the two outcomes that we are providing. Okay, so we have now the pitch match state created. Now we have to go and create the other states. Is the pick state that depends on the TU state base. This is the same as we did last time. So in this case, let's change the name here. Instead of my sleep, let's put pick state. Then we have the init. It initializes itself, and then we don't need this sleep time because we are not using the sleep time here. Great. And then let's see, and the get match state, instead of my sleep match state, we have to put the pitch match state that we have created before. So change it also, and that's it. Also, this class is already done. Let's go for the final class, the one that creates the Qt plot there. Also, I haven't investigated on how to create this Qt thing because it's a lot of work for just graphical tools. So I didn't have the time. In case that you want to experience with that, you can learn how to create the different boxes and forms and etc. to get information in the Qt window that opens the R commander. You remember? Okay, so I'm going to leave most of it like it was in the previous state. But the one thing that we have to change, of course, is the name of the class. So instead of my sleep tool, let's put peak tool. Peak tool, then it initialize the R commander. Instead of my sleep, let's put peak in non-capital. Then instead of my sleep, let's put peak in capital first letter. And instead of my sleep state, let's put peak state. That is the one that we have created beneath. Great. Then next things, this field property box is the Qt thing that I was talking about for configuring this state. We don't need most of it. Just in order to keep working, just remove the last line. Okay, so remove that. We can actually remove everything, but I haven't experience with that, so I don't know what is the effect is going to be. Just remove that last line that requires a parameter that we are not providing. So just remove it. And then let's go for the next function that you have to create is the new node. It's just write the self name and remove the self counter string, okay, because we don't have the self counter. And then return, instead of my sleep state, you have to return return peak state. And also, because in this case we don't have a time, you don't have to provide the second argument, just the name. So you can remove the self-type box value, but this is only related to the sleep state we are copying this code from. And what else? Then set node properties. Yeah, so here there is a time box that is created here. And just in order to simplify, just remove this here and provide a value like 3.0, for example. If somebody experiences with this more and can tell us how to modify this, we'll be happy to hear. And basically that's it. We have everything now created for this peak state. So let's save it. Let me know if you are not following, okay? So if you are not following, let me know if you are stuck. Then final thing that remains is to modify the manifest. The manifest is here. And if you remember, we have to add here a new line per each state, new state that we want to use in the R commander. So I'm going to copy this last line. We have the one of the drone, the state of the drone, that is a takeoff created here, takeoff tool. We created that on the previous class. So I'm going to copy this, then and modify this as it should be. So how it should be, so we leave this, our commander plane, instead of takeoff tool, what is the name of our tool? It's the peak tool. So modify this to peak tool. It is my robot also, it's for the same robot. And then let's create a different tab. Instead of drone, let's create a tab that is called grasping, for example. So we have to see a new tab in the R commander that show us the peak state. Okay, great. So now we are about to finish. Well, actually we have finished. So the only thing that remains is to launch the R commander. Let's do it. And for that, I have created, or as I mentioned, this grasping launch here. So let's launch that one. So you go to the shell, and let me make it bigger so you can see better. You do the ROS launch, R commander, name of the package that we have, and then the grasping launch file. And then we launch it. You're going to see some red errors, but don't worry too much because it's about the, okay, no, this is an error, real error. So something is wrong here. Let's see what is happening. We should have this solved. Then ROSPy has a really, oh, okay, yeah. So init node, yes. So the thing is, if this happens to you, you can close it. You can close it. So what it's indicating is that the init node is broken. So already has been called this already. Where are we calling this init node? We are calling this init node here. Okay, so in this ROS Pi init node, our commander. Then the thing is that the smart grasper in the inside is calling an init node. So this one is conflicting with this one. So how do we solve it? Very simple. We just comment that one here, and that's all. If you comment it, then the node of the R commander is going to be initialized by the smart grasper. Yes, so you comment that, then save it. And let's go and relaunch it again. Okay, those errors, yes, are related to the visualization of the meshes, but it's not really an error in the real sense. So it doesn't it doesn't make any problem in the simulation of the execution. Okay, so it has started. So how can we see the graphical tools? Well, by going to the tools and graphical tools, and here the R commander should appear. Here it is. I'm going to put it bigger so you can see here, and also let me make it bigger like this, like full. Great. And then this is the code of the notebook. We don't need it anymore for now, so I'm going to close it. And here we have the simulation. Great. As you can see in the R commander, now there is a new tab with a drone name on it. And if you click on it, you will see that there is the takeoff status state. Sorry. If you click on the takeoff, then this is the Qt window that is populated with that state. So this makes no sense for that state because we are not using it. So the thing is that we are going to add this state into a state machine. And there it is. So we have the state added there. Great. So far, so good. So everything, there is no errors here in the shell about this. So great. So it looks like it's working. So now we can test, actually, we can test that this state is working. So how? Well, by selecting it, it's already selected, and then press run. If you press run here, that state will be executed. We can do here, run, and then see here that the simulation that the robot is going to grasp the ball. So execute it. And it should go, and something wrong. Let me see. Something is wrong. Taking off. Why is take off? Oh, sorry. No, I mistake. Yes, this is the drone. No, it should happen. It should appear here. Sorry, there is a mistake here. I didn't notice. It's not the drone that we want to. It's the grasper. Sorry. Yeah. So something is wrong here. Okay, let's go back and see what is happening here. So manifest here is grasping. Yes, my robot. Nobody told me on the chat. Very bad. You are not paying attention. Let's see. This is drone and grasping. So why is not showing here the grasping? Let me see. We have to close this because this is wrong. And let me see. Yeah, so Epson says he's seen grasping tab as big as a button. Yes. So that's how it should be. And Andreas. Yeah, okay. So some people there, I don't understand what happened here. Let me launch it again. Because this is normal. This means that it's been initialized properly. And drone, no. Okay. So why is not? Have I Saved it. Yes. So it's saved. So some people there is working for you. Great. That's great. So it means that for most of the people it's working. So it's only for me that is not. Let me see. Unable to load plugin pickup2 from package R command plane. Okay. So here there is a problem. It's not able to load it. R command plane for whatever the reason. Pick tool. R command plane pick tool. Yes. So I think it's correct. Let me see. Pick tool, yes. New node, biggest state, biggest match state. Yeah, sometimes I do this kind of errors around here. So, and then let me see. Just a second. Let me check the code that everything is correct. And okay, I'm going to take the emergency solution, that is to copy everything again from my previous, when I was preparing the exercise for you. So let me copy. So if it is working for you, it means that I have done some stupid mistake somewhere. So let me copy everything and launch it again. Let's see. And you see that complaints about not parsing enough arguments. Yes, that could be that we have included some arguments in any of the, yeah, here it is, the grasping. So I don't know which stupid mistake did I created on the code here, but here it is. So it is working there. Then if I add the grasping, then the pick, then I add, and here it is. Then I'm going to move it on the side so we can see the simulation grasping. I select the state and I press run. Then it executes here on the simulation. You can see, and it's grasping. Great. Now, you say about the callback. You say about that is there is an error in some place. State machine starting, big user data. Okay, this error in red. I don't know what is the error that you mentioned there, Epson. If you can paste it there on the chat, then I can have a look, because this is some error in the grasper itself. So it's something, I think it's nothing related to the state machine, I think. I'm not sure, but I think it's something related to the the grasping code. And if you paste the comment, the error there on the chat, I can have a look. Then what is remaining? So what is remaining is that we need to reset the wall. So how do we reset the wall? Okay, I need to open again the notebook. So Jupyter Notebook, Smart Grasping Sandbox, and a Smart Grasping Sandbox. And here, if I press on reset the wall, I select this and I press, then, sorry, no, because it's not the same grasper, of course. Okay, yes, pick state name, this 03, you don't have to put it. You don't have to put it, this 03, I think. What you mentioned there on the chat. To return pick a state is here. Pick a state is, yeah, you see? Yeah, it's here. Is the pick a state name doesn't have to contain a 03. Okay, great. Then what else? It remains the reset wall. Okay, so what happens here? That we need to create another grasper. So remember that whenever you create grasper, a smart grasper, is a smart grasper that is for that environment. In that case, it's for the notebook, and in this case, it's for the state machine. So in order to reset the wall, we cannot use the reset wall here in the notebook, of course, because in that case, we should create here another smart grasper. I don't know if it's going to collide. If I execute this, it's going to collide with the one that has been created by the state machine. I don't know. Let's see. Okay. No, so far so good. Yeah, it's okay, but I'm not sure how it can work. So anyway, what it remains is that you have to copy this pick tool and generate another one. This is your homework, okay? So you have to copy that pick tool and then just clone it and create a reset wall state, okay? So you have to reset the wall that instead of calling the pick here, it has to call the reset wall. Then you will have another state that you can add here to the list and put it here. So you can create a state machine that does the pick, then waits, then resets, then waits, and then goes back again to the pick. We don't have the time now for doing this. Too much time lost at the beginning. And then, but that's homework for you. If you want me to review, you can send me an email and I will review that code with you. You can share also with me inside the audience. Yes, Epson says, I think we can use the arguments in the graphical interface to trigger a reset wall call. I presume that you mean arguments in the graphical interface here. Exactly, yes. This is very powerful. I haven't explored this just because I wanted to make it work, this with ROS, and that was a huge work to make it work. And then I didn't have the time to do this, but this is very powerful. You can put a lot of information here that can be captured by your state here. And then you can use this information to take decisions inside of the state or to set the state. So you can have different pick states based on this information here. Like, for example, a sleep state. You can have a sleep state. If you go here, I don't remember exactly here, my sleep, you can add a sleep state. For example, I have added, and this sleep state, you select it. It has a 3 seconds sleep state, but you can modify this to 5, for example, and save it. And then it will sleep for 5. And we can do, for example, is to connect this sleep into when done, we can connect to the peak state. To the peak, then we have this. So we have this state machine. I will select this sleep state as the start state. And then I'm going to execute the state machine. And it's sleeping here for 5 seconds. And then it jumps into the peak. So at some point in time, 5 seconds already gone. Oh, okay. So it took a long time. I don't know why 5 seconds. That was a long 5 seconds. But anyway, so it jumped from the sleep to the peak. And then you can then afterwards reset the wall, modify the position of the wall, and then execute a peak again, etc., etc. So please experience with all this and send me emails, questions, whatever you have related to this job. And that's it. So we are done for today here. I hope that you enjoyed this session. For the next week, we are going to work with industrial robots. So we are going to how to just move it. We are going to do experiences with industrial robots using ROS. And once we have this kinetic thing solved, I promise that I will use these visual states for showing you in an extra class how to use it for generating visually state machines. Okay, great. Remember, if you want to learn ROS fast, remember that we have this Robot Ignite Academy that I'm going to share with you, that it's the fastest way to learn ROS. So what about learning in 5 days? Ross, what do you think? Is fast enough or not? You can learn using Python, using C++, and we have many, many subjects like navigation, perception, manipulation, and many others, autonomous vehicles, OpenAI, 3D navigation, many how to program different products that already exist, etc., etc. And remember also that we have the ROS Developers Conference online. That's a conference for attending online where we are inviting experts to explain to the people how to do things. And you will be doing the same things that they are doing live at the same time as they are doing, and in the same way as we are working here in the live class. So don't forget to this. You can check some information here about the keynote speakers, but there is an open call for tutorials. So in case that you would like to present something to that conference, you can do it. You can submit. I don't remember exactly when is the final date for the submission. I think it's here, call for tutorials. Yes, the final date is not here. Here it is. Okay, 30th of April. So before the end of April, you should have submitted your proposal for talking. Those are key speakers, okay? So these are like big players. And then in case that you would like to also be one of the big players, submit your proposal. And that's it. I hope that you are enjoying a lot the classes, and this is becoming dark and I didn't realize. So that means that it's time to leave. So see you next week on the ROS Industrial class, okay? Thank you, ROS developers.